Okay, we've got to work out the area of this pentagon. So where do we start? Well, first notice that it's symmetrical. 12, 12, 8, 8, and these two angles are the same. So that's probably going to make life slightly easier. Now, with area questions, you have to divide them up somehow. We can't just we don't have a formula for the area of a pentagon, for example. So we have to divide it up and do it bit by bit. So this question comes down to what's the best way to divide the pentagon up? Well, we're going to divide it up from the corners. I could go from there to there, but that would split this 105-degree angle they've given us in two. And as a rule of thumb, that's probably not a good idea because they've given us that. We want to use the whole angle. It doesn't make sense to split up into two and try and work out what the two different halves are. So probably going from there to there is not a good idea. And likewise, going from there to anywhere else is not good because we're splitting the angle. So that just leaves this. And because it's symmetrical, it's the same as doing that. And that's the best way to split it up. So let's work with this. So, look at this. Look what we've got. We've got an angle and two sides of a non-right angled triangle. So straight away, we can use the formula for the area of a triangle, which is half AB sine C. It's area. And we've got the area of these two straight away. So that's great. So let's label the sides. Sine C, that's the angle. So that's big C, the angle. So that means the opposite must be little c. So it doesn't matter which you call A and B. Let's do it that way around. So that's half times A is 12 times B is 8. Sine, the angle is 105. Okay? Just stick that in your calculator and you get 46.364 something. Something. Okay. Put that in your calculator's memory. Throughout the whole of this and questions like this, you always have to work with the precise value. Don't just write it down as 46.36, say, and then use 46.36 in the future. Get it in the memory so you can recall the exact value. Okay, so, well, that's a good start. We've got the area of this and this. So now we just need the big triangle in the middle. Now, we don't know the height, we know the base, and we don't know this, C. But look at this. Again, two sides of the angle. We can easily work out C using the cosine rule. So let's do that. So the cosine rule is, I'm going to do it, it's given to you in terms of a squared equals b squared plus c squared minus 2bc cos a, but I'm going to rewrite it with c squared as the subject. So c squared is a squared plus b squared minus 2ab cos c. Okay. So c squared is 12 squared plus 8 squared minus 2 times 12 times 8 times cos 105. Great. So that gives us c. So put all that in the calculator and you get c squared to be 257.693 something. Take the square root and c turns out to be 16.052 something. Again, put that in your calculator's memory and work with the exact value. So we know C, it's 16.052 something. Excellent. And we want to work out the height. These two are the same, of course, because it's symmetrical. So let's call the height h. So if that's 13, half of 13, 6.5. So we have a right angled triangle. We know the hypotenuse and this side here. So we can just use Pythag to work out h. Easy. So using Pythagoras, c squared is h squared plus 6.5 squared. And c squared is that. So 257.693 whatever equals h squared plus whatever 6.5 squared is. So rearrange, h squared is, you've put that in your calculator's memory, haven't you? So let's just work with that rather than that actually. So h squared is c squared, which is 16.052 whatever squared minus 6.5 squared. Yeah, you wouldn't have that in your calculator's memory, you've only got that, so you can just dig it out of the memory and square it, and it will give you that. Anyway, so h squared turns out to be whatever, take the square root of it, and you get h is 14.620 something. Put it in your calculator's memory. Okay, so we've got the height now, 14.620 something. Brilliant. So now all we have to do is use half base times height to work out the area of the triangle. Let's do it for the whole thing, the big triangle. We could do it for each half, but it's just giving yourself extra work. So that whole large central triangle, area, half base times height. So the area is half, the base is 13, and the height is this. Okay, so the area turns out to be 95.031. Something. Put it in your calculator's memory. Right, well, we've done it. We've got the area of this central thing, and we've got the area of both of the two side ones. So the total area is two of those. So this bit here and this bit here, which is 246.364. Dig that out of your calculator's memory. Plus that, which is this whole central bit here, all of that. 95.031 something. And the final answer turns out to be 187.760. 187.760 something. And it wants it to three significant figures, which to three sig figs, that 7 pushes that up to an 8, is 188. This is centimetres squared, isn't it? That's it. It's not too challenging if you divide it up sensibly. And like I say, general rule of thumb, try and work with the angle that they've given you. It would be a bad idea to split it up like that, for example. So yeah, all of these formulas are on your formula sheet. Not that you should need them, they should be in your memory. But yeah, you can definitely do that.